Cloud Run is a fully managed serverless compute platform to run container based workloads. Well, it was launched way back in 2019, but now it's reborn with a lot of exciting new features. In this reincarnation, Cloud Run is set to revolutionize application development, but this time for AI based applications. So, what is this new feature I'm talking about? I am referring to the serverless GPUs. In collaboration with Nvidia, Google Cloud has launched L4 Nvidia GPU availability in preview mode right now. In this section, I want to cover why at all do we need serverless GPUs. If you want to invoke an AI model, the one that is widely used option is by making an API call. You just need an API key and use a hosted service like Vertex AI, which exposes the endpoint at aiplatform.googleapis.com. And then you start invoking whether it's a Gemma model or a Gemini model, and then you get the results back. But at the end of the day, it's still an API call. So the requests are going out of your network. In some scenarios, there could be a company may have very stringent requirements where they don't want to let the data go outside the network. They want to do everything locally. So, in such cases, you would have to download the model and then make the calls. For that, you would need expensive compute like GPUs. So, that is where Google has come up with this option and they have bundled it with the Cloud Run so that it is dispensable. You use it as long as you need and then you return it back. And the collaboration with NVIDIA, Google Cloud, and Olama makes this magic happen. That is what we see on the right side, where we basically two layers in that image. The first one is the Olama engine, and then the second one is the Gemma model. You download both of those and then you package them into an image, deploy them into the artifact registry, and then save them in the artifact registry, and then from there you deploy to the Cloud Run. And while deploying to the Cloud Run, you specify your compute options like the Nvidia L4 GPU on which this model will be running. From that point onwards, you can make calls to the model. Everything will be contained within a sandboxed environment, and you invoke it and you get the results back. Once that is done, you can crash it completely so that you don't pay any cost, but you have the benefit of using the GPUs while the requests are being served. Briefly go through all the 9 steps and then we'll be performing the same steps one by one. The first one is the prerequisite. Number 0 is to submit a GPU quota request form. Once that is done, you will get GPU quota allocated to your project, and then you can start using the GPUs. Step number 1 is to enable the APIs. So the ones that you see at the bottom, those are the APIs that we'll be using: Cloud Run, Cloud Build, Artifact Registry. Followed by step number 2 to enable the IAM roles and permissions. In our case, we are keeping it very simple and using the owner role. Number 3 is to set the environment variables like the project ID, region, location, etc. Number 4 is create a Docker repository in Artifact Registry. Number 5 is the one which actually does the build. It builds the image and then loads it into the repository. Number 6 is to create a service account. This is the service account that we'll be using, Olama service account. It's a best practice to have a dedicated service account for each Cloud Run service. So once that is done, So step number 7 is the main step where everything comes to life, the deployment step. Number 8 is how we do an invocation to the Gemma service. Number 9 is to clean up all the resources. So all these 9 steps I have detailed out in the README file, and now we'll be performing each and every step. So let's go down. Step 0 is the prerequisites to get a request for a GPU quota by entering details in this page. You will be entering details like email address, project ID, project number, the purpose of usage. Once you submit, you'll get a response from Google typically in a day's time, and the default quota of 7 GPUs will be allocated to that particular project. Once that is done, um, we can continue with other steps. Step number 1 is to enable the APIs. So let's copy that and then enable the APIs. I've already done that, but I'm just doing it again so that we do all the steps here. That's done. Step number 2, we are not doing anything because we are keeping it simple and using the owner permissions. If you want to know and want to fine grained IAM permissions, you can um, look at this page and this section. The required roles gives you the all the fine grained roles that you can use to further lock it down. So we are now can move to step number 3. As you can see, we are setting some environment variables and project ID and region. If you get this warning while setting the property, you can ignore that. That's not an issue. Now we are at step number 4. This is to create a repository. I have already performed this step. So if you see just a few minutes back, the Olama repo has been created. Moving on to step number 5, we are going to build the container image. I want to separately call out the build and the deploy steps. In the build, it does a Docker build and takes the Docker file as an input. In that, we have 2 layers, the Olama and the Gemma. They get packaged into an image that you see in the middle, and then that image gets copied into the Docker repository in the artifact registry. That is the build step. And in the deploy step, we do the normal gcloud deploy to deploy to the cloud run. While doing that, we specify a compute that we require. So we have some new flags for GPU that you see in the yellow color here. We specify the number of GPUs and the type of GPU, that is Nvidia L4. Once we do that, our service will be provisioned with that infrastructure, and then we can go ahead and start using it and making calls to the model. Container image. So um, let me go through this repository as we need to understand that. So the 2 key files here are the Olama backend folder and then the README file, which we are going through, which has all the scripts and the steps. So Olama backend, if I go inside that, has a Docker file. Let's go through this Docker file. When we do the build, it uses this Docker file to build the image, what it does is it uses this Olama base image and reset the port. Normally, the Olama default port is 11434, but in this case, we are using 8080. We specify the model, which is gemma2 9B, and then we pull the model with this command, Olama pull $model, which is gemma2 9B. Let's go back. So that is what happens in the build, step number 5. And notice that we are using very high machine type to do the build so that it does it quickly. Let me get the code itself from here. This is the repository code. I'll use this option. I'm just cloning the repository. So it has downloaded the code. CD Olama backend. We have the Docker file here. So we'll run the step number 5 at this location because we want it to pick up the Docker file from the current directory. Step number 5 again. Hopefully it should run fine this time. So this is the step which will take 7 or 8 minutes. Built-in image step is now complete. We started at 15:06. Now it is 15:14, and the build has been completed. So scrolling up, this is the command we ran, and this is the build output. It is similar, and this is the model 5.4 GB gemma2 9B model, and we should have image uploaded here. Olama Gemma, and this is the image. You can see virtual size 6 gigabytes. Okay, let's move on. We are done with step number 5. Now we are on step number 6. As I mentioned earlier, it's a best practice to use a service account for each cloud run service. Let's take that. So we created this Olama service account. Just see that you can notice that we are not assigning any other roles for this Olama identity because we are not making any calls to the Google APIs. We are on the most important step, number 7, where we deploy the image Cloud Run. This is the most important step. So let's take a minute to go through this, the key parameters. So Olama Gemma is our service. You can see this new parameters, new fields, GPU, which is number one GPU. and the GPU type is the Nvidia L4, max instances 7, and you can see that we have specified no unauthenticated invocations and the service account that we'll be using. Let's take that and run that. I'll specify number 32, US Central 1. So we are running step number 8. This is to set up the proxy. Number 32 again, US Central 1. You can see that localhost 9090 is now proxying the request to the our Olama Gemma cloud run service. Now let me invoke that with the curl command and sending a request to through the localhost. And here you can see we are asking a simple question: why is the sky blue? Which is the equivalent of a hello world for a Zone application. I will do that in a separate command window. Just to be sure, I will set the environment variables once again. While that's running, I'll just copy this back again. Go to the second window. Now let me invoke it. You can see here we are getting the response. Understandably, it's a bit. There is another option with which we can convert this in making it bit pretty through the Olama web UI. But let's see the response. It says because of the Rayleigh scattering, that's the reason why the sky is blue. So we got our output. So that's it, guys. Uh, Now we're at the last step, which is step number 9 to clean up the resources. It's very important. Um, Let me stop this proxy server and I'll run this command to do the cleanups. Say yes. Now the service is gone. We are deleting the Olama repository. That's gone. Now we are deleting the Olama service account. That's gone. I think everything is done. Okay. Thanks for listening. Thanks for watching the video. Let me know if you face any issues in the comment section and I'll be happy to help. I will add the link to this repository in the description. Thank you. Lastly, I want to talk about the impact of cost as a result of running this example. I ran this example on the 3rd of November, that is yesterday, and you can see that we are using here three services: Cloud Build, Cloud Run, and Artifact Registry. And if I add all of them up, Cloud Build, that is £1, Cloud Run is zero point 0.3, and Artifact Registry is zero point 0.1. So if I add all of them up, it is less than £2. And in fact, I ran this twice. So Effectively, the cost is less than 1 pound.